Hey guys, we are here once again at Just Math Y'all, and hope you are learning. Um, some of y'all are skipping through the videos, which is fine, but a 10-minute video you shouldn't be finishing in 2 seconds. And so, yeah. Anyway, you're supposed to be copying down the examples and writing and keeping them in your notes so that you can use them on the test. So I hope you're getting what you need. All right, so today we are working on continuity. This is video number 2, and we did video 1, which is determine if a function is continuous at a point or at a point, and we used a graph to do that, and we did it also with an equation. That's their checklist. And now video number 2, we're going to determine intervals of continuity. All right, so basically when it comes to continuity and where a function is continuous or not, we have two definitions here for polynomials, or theorem, excuse me, it's a theorem for polynomials and rationals. A polynomial is continuous for everything. So if you're looking at an equation and you want to know if it's continuous or not, it's continuous on its entire domain. And so the domain for a polynomial is negative infinity to positive infinity. So if it's polynomial, it's continuous from negative infinity to positive infinity. Now, a rational function is continuous for everything except for where the denominator does not equal 0. So basically, this is very much like domain. It gets different from domain when you start looking at piecewise functions. Okay, so now if we go back and look at the piecewise function we had on the very last one, this particular function has a domain of every x. This particular function is defined. That's what it means to be a domain. If it's in the domain, it is defined for all x's from negative infinity to positive infinity. It is defined for everything, but it is not continuous. Okay, so just because domain is not always going to be the same as continuous, but here we go. All right, so determine the intervals where the function is continuous. All right, so now the first one is a polynomial, and the domain of a polynomial is negative infinity to positive infinity, and so it is continuous on its entire domain. So this one would be continuous on the entire interval. So it's a polynomial. So it's continuous on the whole domain of negative infinity to positive infinity. Okay. Now, the other two, okay, they are rational functions, and so we need to look at that denominator and determine where that denominator equals 0, because it's not going to be continuous at those points, because it's not defined at those points. So let's look at the h. So now I specifically gave you one that needed to be factored, and because I was looking at your homework, and some of y'all are struggling with the factoring, and so I wanted to do this factoring. Okay. One of the ways to factor is a new method that a lot of people call bottoms up, and so I'm going to do that method because that's what it appears that you're doing on your homework, and you're getting them wrong. And so here we go. So I need to just take 6x squared plus 7x minus 20 and set it equal to 0 and solve. So I'm going to factor it. I'm going to take the 6 and multiply by the 20. Is that what I'm going to do? Is this the right number? Yes, it is. 6 times 20 is 120. And I actually dropped the 6. Okay. I need two numbers that are going to multiply to give me 120 that are going to add or subtract. In this case, subtract to give me a 7. All right. So I'm going to think about that for just a minute. It's not 12 and 10. It might be 15 and 8. 15 and 8. So it's 15 and 8, and it's got to be a negative 8, so it's 15 and negative 8. So I put my x here, my 15 here, and my negative 8 here, but these are not my factors. And this is where a couple of y'all are struggling. Because we changed the problem, by moving that 6, we multiplied by 6, we need to come in here and divide by 6. Okay, and so now that's going to become x plus, reduce that fraction, 5/2. So as a factor, it would be 2x plus 5, and this would be x minus 4/3, and that becomes 3x minus 4. And so then I can see that my x is going to be negative 5/2 and positive 4/3. So those are the numbers that x cannot be. So this thing is going to be continuous on every point except for these two. Okay, so my intervals of continuity are going to be negative infinity. Hold on, let me draw it on the number line. So my intervals for continuity are going to be negative infinity to negative 5/2. And then the middle one, which would be negative 5/2 to 4/3. And then the big one, which is 4/3, or the last one, to positive infinity. So that's the answer here. It's not a very good highlighter pen combo. Apologize if you can't read that. I wanted to do that so y'all could see the factoring. Y'all should be able to factor. This is not the only method to do it, but I had looked at some of y'all's homework, and this is what I was seeing. I was seeing the factors they weren't right, and it looked like this was where y'all messed up. So here we go. All right, so now the next one. Okay, the next one, we've got to know where its denominator equals 0. Okay, so x squared plus x plus 1 equals 0. I'm going to try to factor it, and it doesn't factor. All right, so now I need to use the quadratic formula. So negative b plus or minus the square root b squared minus 4 times 1 times 1 all over 2 times 1. Okay, so now what happens, and I'm not going to go much further than this, do that radical, I get 1 minus 4, which is negative 3, not real. We're not dealing with imaginary numbers. We're not dealing with it. Okay, so this one is not defined in the real. All right, every number you put in here is going to be positive. It's not going to be 0 no matter what number you put in this denominator. Okay, so this is going to be continuous everywhere. Continuous everywhere because there's no exceptions. So this one is continuous. Negative infinity to positive infinity. All right. Okay, what was our next thing that we wanted to do? Let's see. The intermediate value theorem. All right, the intermediate value theorem says that if it's continuous on an interval and L is the number strictly between, then there exists at least one number, C, satisfying f of C. Well, so what in the heck does that mean? Okay, we're going to come back and we will do a third video on intermediate value